Right, this is our summary video for multiplying polynomials by monomials. This is 14.3. There are a couple different ways we can visualize multiplying monomials. Really what we're doing is we are using the distributive method and multiplying everything by that number in front. So one way we can visualize this is by using the area model. In this case, I've got my first term 5, and I'm multiplying it by each other term here. So 2k squared, k, and 4. Now inside each of these boxes is going to be our total. So in this first one, I'm doing 5 times 2k squared. Now I can actually visualize this in even smaller parts by first just doing the 5 times 2, and then applying that next to k. So if I were to look at that, this can be reduced into 10k squared. In my next one, I have 5 times k, so that's actually just going to be 5k. And then in the final one, we have 5 times 4, aka 20. So in this case, our final answer would be 10k squared plus 5k plus 20. You may have already recognized that by doing the distributive method up here. So doing that 5 times 2k squared to get 10k squared, 5 times k to get 5k, and finally the 5 times 4 to get the 20 itself. Both of them will show you the same thing. On this next one here, I'm going to continue to use the box method. So at this point, I'm going to erase this just so that I have some more room. We've got 9a squared b squared, and we are multiplying that times negative 4a to the third b to the fifth. Now in this case, there's only one other term. This is a monomial by a monomial. But we are going to break it down into a bunch of different little parts so we can focus on them individually. First thing, I'm just going to focus on the coefficients, so the numbers at the beginning. So this is 9 times negative 4. If I visually want to represent this in a different way, we are regrouping, doing 9 times negative 4, multiplying that by our a values, so a squared times a to the third. And finally our b values, b squared times b to the fifth. This allows us to look at these individual parts. This also is partially due to when we get to this a squared times a to the third. First off though, we're going to start at the beginning. 9 times negative 4 is going to be negative 36. When we have something like this on a squared times a to the third, when we are multiplying something with the same base for exponents, we are going to add the exponents together. So it's really going to be a to the second plus, or a to the 2 plus 3. So this is going to reduce down into a to the fifth power. And finally, again with our last one, we've got b to the second plus b to the fifth. Both of them have the same base, so we're going to add those exponents together to get b to the seventh. With these ones down here, we would still find those answers. And by multiplying them together, because generally with how we do algebra, we can just smush them all together so that our final answer would be negative 36, a to the fifth, b to the seventh. All right. Finally, looking at our last one. Again, we're going to just erase so that I have space. We've got negative 6v squared w squared. All right. A lot of different little parts for that, but that's okay. Multiplying it by 3 different parts, we've got v squared. We got negative 11v squared w to the fifth. and 6w to the 4th. I'm breaking these down into different sections just so that I can focus on them individually. All right, first off, we've got negative 6v squared times w to the third times v squared. At this point, I have no other coefficients, so I'm going to have negative 6 really times 1. There's nothing really there for us. We're going to have v squared times v squared. There's those two. And w to the third, also technically times 1, or we can just leave it as is. Then going through, I've got negative 6 times 1, so negative 6. V squared times v squared, same base. Multiplying, so we're going to add the exponents to get v to the 4th. And w to the third times 1 is just w to the third. All right, now we've got our next one. We've got negative 6 times negative 11. V squared times v squared. And w to the third times w to the 5th. Now we can go ahead and do these multiplications as we put them all together. So negative 6 times negative 11 is going to get us 66. V squared times v squared, same base. We are multiplying, so we're going to add the exponents. So v to the 4th. And our last one, again, same base. We're multiplying with exponents, so we're going to add them together. So this is w to the 8th. And finally, we have our last one. We've got negative 6 times negative 6, times regular 6. V squared, there's no v's in this one, so v squared times 1. W to the third times w to the 4th. And finally, putting all these calculations together, negative 6 times 6 is going to be negative 36. V squared times 1 is just v squared. W to the third times w to the 4th, same base. We are multiplying the exponents. We're going to add them together, so w to the 7th. Now when we finally write it together in our final words, I'm going to start with the left side here. So negative 6 v to the 4th, w to the third. There's no negative there, so this is a positive number, so plus 66 v to the 4th, w to the 8th. This one now has a minus, or negative, so minus 36 v squared, w to the 7th. So with each of these, utilizing the box and breaking it down into those pieces really helps us look and make sure we're not making a mistake somewhere else. You can go through and look at all these different points and just go, hey, what is this whole thing times this? What is this whole thing times this term? Make sure you include that negative or subtraction symbol if it is included beforehand. So as we can see, that does change some of our outcomes. So again, we're just multiplying it by each of those terms. I visually like to put it in the box and break it apart. We can write it in that distributive way, looking at differently. So negative 6 times the 1 times the v squared times v squared. So we can, again, write this all separately out in a big line, adding each of those terms as we multiply them. Both of them will give you the same way. Just depends on how you feel like writing them out. I personally like this area model because we are going to continue to look at this as we go